So just going to introduce why the world is shifting to using model-based design and what are the advantages and benefits of using this technique. So for those of you that are already familiar with embedded system or microcontrollers, to build real devices, one way or another, you need to write code to embedded systems or microcontrollers. And the traditional method of doing that is we write C code, right? C++ code. But the pain point is that writing and debugging C code is time consuming, right? And as the design gets more and more complex, then implementing those kind of algorithms also keeps getting more complex with traditional coding methods. And it's also not easy, once you've written that, to deploy to microcontrollers. It's not easy to find affordable hardware, especially all of us are students over here, right? So we all, there's budgets and everything. So it's quite difficult to find affordable boards. So these are the pain points. So now we come to the solution part. So why should we use model-based design? Everything that we write in C code can be duplicated, but by using drag and drop blocks. So you don't have to write a single line of C code, and nothing needs to be debugged. And that's the part that takes a lot of time once we write the code, debugging and everything. But in MATLAB and Simulink, you can develop as complex algorithms as you want in a simulation environment, and then through block sets in MATLAB Simulink, right? But then the real question is, after you develop these block sets, how do you convert that into C code? Because once you have these in MATLAB Simulink, right? This is the design of the control algorithm. But to convert this to this, because this is eventually what's needed to make the microcontroller function, how do you do that, right? So that's where this comes in, automatic code generation from MATLAB Simulink deployed to your microcontroller. And that's where we're going to learn about Waijung 2 today, which is a Simulink add-on block set designed for ESP32 microcontroller family. And it's based on the MATLAB Simulink code generation technology, right? Which automatically generates C code from Simulink models, Stateflow charts, MATLAB functions, everything that we will see in MATLAB Simulink. And just at a click of a button, after you design your control algorithm on the software, just with one click of a button, it will automatically convert everything to C code and deploy to the microcontroller. That's the power of this software. And it works with all Simulink blocks. So it's compatible with anything that you want to design, right? So today we're going to work with ESP32 microcontrollers, but we have recently released Waijung 2 for Zynq 7000 microcontrollers as well, that I mentioned in the company introduction video. Maybe at some point we will be conducting a workshop about that as well. So what can we do when we combine, model-based design technique with MATLAB and Simulink and with Waijung 2, right? It allows you to extract the entire benefit of the MBD workflow. So if you just use MATLAB Simulink, then this is what you will have. You'll be able to simulate, whatever you want to simulate. This is on MATLAB Simulink. But to convert it to a real device and make it into a real product, and you use Waijung 2, this is what you can have. You can simulate exactly what you want to do, and then you can deploy that and convert that into a real product, right? And so this really allows you to work with affordable, powerful, low-cost hardware to build real devices. That's the power of this Waijung 2 software, right? And another big benefit is that we have an IoT-specific block set, which is the focus of today's workshop, right? Which means that we can minimize hardware components by using our specific IoT block set, and we can build devices that are controlled through a web application interface. So you can see over here, this is a GIF that I've prepared. So I am controlling, if we didn't have this web application interface, then to do these things, I would also need to have a switch to control these lights. I'm talking about real hardware. I would need to have potentiometers or sliders to control the brightness of the LEDs. But because of IoT innovation and technology, we can now do this from the web page. We need minimum hardware, and you will see this when you work with hardware today. You'll see there's 4 jumper wires, 1 LED, 1 LDR. That's all. That's all we need, because that's the power of IoT and the specific block set that we have. We can minimize the hardware, and we can get maximum results. So today's agenda will be working with a simple LDR and LED, and it'll be something like in a dark room the light will turn on automatically, and in a bright room the light will turn off automatically. That will be the focus of today's projects, and there can be many applications and uses: automatic street lights, any place that you want to control the light based on the surrounding environment or surrounding light, right? So to eventually get to the end of the workshop today, to achieve what you saw over here, we have to walk step by step, right? Since many of you are unfamiliar with MATLAB Simulink, first we have to work on that. We have to show how MATLAB Simulink works and how Stateflow functions work, how you can first simulate something that you want to create on a real device on software first, because that's always the first step. You have to test something that you want to do on software. If it is working, then that's when you deploy it to the hardware to see and build that real product, right? That's always the process. So the first step is always, today's workshop as well, the first step will be to do what we want on MATLAB Simulink, okay? So that'll be the introduction. So we'll be modeling, simulating how to read the LDR sensor in Simulink, how to model driving the LED light to the LDR input, also in Simulink, and we'll be using some dashboard components that help in visualization of like your results, right? So this will be the first project, and then there'll be a short exercise for all of us to see how much we understand and whether we can apply what we learned over here, okay? And then moving on will be the next step of the project, which this one is purely software, okay? 1A. 1B will be when you deploy what you have designed today to real hardware, and you will be creating a real device. That will be project 1B, when you'll be deploying the Simulink and Stateflow and MATLAB model to ESP32 microcontrollers. So we have the hardware prepared at the back, right? Using Waijung 2, and that's when you learn about what Waijung 2 can do and how automatic code generation works. And what I think you will find very interesting is that we will be introducing to you a concept called external mode today. So what external mode is, external mode creates a communication channel between real hardware, in this case ESP32, and MATLAB Simulink. So as you can see in this GIF as well, any changes that I make over here, it'll be reflected in real time on the hardware. This is what's external mode. You can monitor and tune parameters in real time from your MATLAB Simulink environment to your hardware. That will be the focus of this project, right? And this will be the hardware setup. Now, lastly, by the way, these are all the same projects. It's just step 1, step 2, step 3. So once we do this, now this is controlling the hardware from MATLAB Simulink. And eventually we will get to a point where we will control the same hardware, but through a web page. This is where the IoT part comes in, right? Everything that you've designed on MATLAB Simulink, you will then deploy it to a web page and then control the same hardware, but through the web page. So eventually we will get to this point. This will be happening in the afternoon. The morning session will be focused on, introduction to the MATLAB Simulink, Stateflow, and Waijung 2, right?